Okay, number 9 says, find the missing side of a right triangle whose leg measures 48 and the hypotenuse is 50. So here's my right triangle. So that's 48. It doesn't have to be drawn to scale, does it? Whose leg is 48. It's obviously not drawn to scale. And we're trying to find the missing side. So we'll call it x, whatever you want to call it. And it says it's a right triangle. So really, it's just Pythagorean theorem again, isn't it? Right? It's kind of weird that we would put two of those in there, but that's okay. The number's going to be a little bit big on this, so definitely help me out because I have no idea what 48 squared is. So x squared plus 48 squared equals 50 squared. Make sure you put these in the right order. A lot of people are just going 48 squared plus 50 squared equals x squared. You can't do that, can you? Hypotenuse has to be the one that's out there by itself. Don't forget that. So x squared, what's 48 squared? What is it? 2304? Wow. 2304. And this is what? 2500? Okay, subtract 2304 from both sides, and x squared is, what is it? 196. All right. Oh, that comes out even, doesn't it? Yep. Square root both sides, and what is that? 14. Okay, and there it is. I guess that's a special triangle, isn't it? 7, 24, 25. Yep, I remember that. That's not one we use very often, but if you knew it, if you remembered it, right, divide both those by 2. Right? So that's a 24 and a 25. And if you remembered it, 7, 24, 25. Very similar to like the 3, 4, 5 triangle. That would have saved you, wouldn't it? Saved you a little bit of work, but you'd rather do the work? Okay, that's fine. Let's go to 10. All right, so let's find the perimeter of a square if the length of its diagonal is 16 inches. So let's draw, we drew a square already, and then the diagonal, that would be the diagonal right there. And that diagonal is 16 inches. Find the perimeter of the square. So basically, now if it's a square, it's a right angle, isn't it? If it's a square, that means both of these sides are exactly the same, aren't they? So what kind of a triangle do we have? We have 45. You could do this a couple different ways. You could do Pythagorean theorem, x squared plus x squared, or you can realize it's 45, 45. Do you remember what the relationship is? Hypotenuse is what? The square root of 2 times one of the legs, right? So what's the hypotenuse? 16. So the square root of 2 times one of the legs, or the square root of 2x. Divide both sides by the square root of 2. Now you might have been able to just remember that off the top of your head, and that's fine. You could have gone 16 divided by the square root of 2, couldn't you? Can we simplify that just to make it a little bit nicer? What's 16 divided by the square root of 2? It's the 16 square root of 2 over what? 2. That goes what? 8. So one side, just one side, is 8 square root of 2. It doesn't say one side. What does it say to find? The perimeter. So if I know one side, what do I do to find the perimeter of the whole thing? Yeah, you could add it, 4 times, or just multiply by 4. That's what I would do. So I would go 4 times 8 square root of 2. That's going to give me my perimeter. So my perimeter is what? 32 square root of 2. Again, there's really no reason at all. Did you need a calculator for this at all? Not one time. Okay, there's no reason to write it with a calculator. Just write it like this. It's just a lot simpler. I know what you're thinking. In the last class, they're basically telling me that, well, you make it too hard, we can't use a calculator. You're telling us not to use a calculator. But really, I'm trying to make it easier for you. I really am. It's a lot easier to do this without a calculator than even punch it in a calculator. Michael?
Why would you put it over 2?
Because this is, I skipped a step. If you remember, it's called rationalizing the denominator. We multiply the bottom by 2 and the top by 2. Do you remember doing that? So we get rid of the square root. Square root of 2 times square root of 2 is 2. That's where we got that. And then 16 square root of 2, that's how we got that. This 2 canceled out with the 16 8 times. All right? We go to that? All right. Let me pause this for the next class because we're almost out of here. Somebody have a calculator ready to punch some numbers in for me? All right, what we're going to do is we're going to solve for, oops, I always forget to do this. Make my pen so I can see it. What we're going to do is we're going to solve for x. Now if you look at it, now I know you weren't here for the first part of this chapter, but we did a lot of Pythagorean theorem and stuff like that. Now, what I'm telling you is this. You weren't here for the first half of this review, so it's going to be your responsibility to go to YouTube if you need this chapter and see the stuff that I did from 1 to 10. All right, everybody understand that? So that's going to be your responsibility. I'm starting at 11 with you guys, and I told them to look at 11 to 20, right? So, because they weren't here for that. Yeah, Zach.
Yeah, did you do the second half of 11? Because that's the
I haven't done any of 11 yet. 11. That's the quiz. Right, that was whatever was on the quiz. We only skipped one lesson from chapter 11. So it only went 5 sections. We did 4 of them, and that's all that's going to be on the final. All right, we got to do this. Ready? What are we going to use here? Are we going to use Pythagorean theorem? Can we use Pythagorean theorem on this? You guys watching? Up here. We cannot use Pythagorean theorem because I need at least 2 sides to do Pythagorean theorem. But I do have an angle, and I've got a side, and it's a right triangle. So what do you think? I'm going to use trig functions, right? Yeah, this is adjacent and hypotenuse. David, what is it? It's the cosine. So it's the cosine of what? 42. You always take the cosine of the angle. Is equal to the adjacent over the hypotenuse. The adjacent is x, the hypotenuse is 12. Right? Get x by itself, multiply both sides by 12. And x is whatever that is. Is somebody going to do that for me? 8.9? Okay. Because it does say round to the nearest tenth, doesn't it? So there you go. Right, here we go. It says find x. Now this time x is not one of the sides, it's an angle, isn't it? So right off the bat, what are you thinking? I'm finding an angle, think calculator-wise. What are you thinking? Say it. Inverse, right. It's the second function on your calculator, okay? That's what should be popping in your mind right away. So let's see what we got. We got this side and we got this side right here. What is this side 6 to this angle? It's opposite. Which side is the 11? Which trig function is opposite over hypotenuse? It's the sine. So it's the sine of angle x is equal to the opposite over the hypotenuse. Now, in order to solve this, you don't have to write this down, but I'm going to. This is when Wendell said use the inverse, okay? So use the second function on your calculator. So it depends on what calculator you're using. If you're using a TI-30XA or something equivalent to that, you hit 6 divided by 11, hit equals, then you hit second function sine. If you're using a graphing calculator, you would hit second function sine first, and then you would put 6 divided by 11, then hit equals. Either way, what do you get for number 12? About 33. And look what it says, round to the what? Nearest degree, so we just do 33 degrees, no decimals. Alright? Alright, let's move on to the next ones. It says 24-foot ladder makes a 58-degree angle with the ground. So here's our situation. Here's our ground. We'll consider this part right here to be the ladder. And we'll say it's 58 degrees. Again, it doesn't have to be perfectly to scale. That's good enough. Now, if it's against a wall, we're assuming what? That the wall and the ground are what? Parallel. Yeah, that'd be a weird wall. Okay, it'd be the floor then, wouldn't it, if it was parallel to the ground? So it's perpendicular. It says how many feet up a wall, there's the wall right here, will it reach? So what are they asking for? They're asking for that distance right there. Does it make sense? Alright, and it says 24-foot ladder, so this length right here must be 24 feet. They don't even ask anything about the ground, do they? Okay, so we don't care about that. We care about how tall the wall is. The ladder is 24, and then this is the angle. All we have to do now is just use a trig function and solve for it. So which trig function are we going to use? Sine, opposite over hypotenuse. So it's the sine of 58 equals opposite over hypotenuse. The math is easy. Multiply both sides by 24. All right, calculator people, give me something. 20.4. Okay, good. There it is. It's feet. I'm not marking it wrong if you don't put feet, but you probably should put that on there because it's how many feet. It's not hard, is it? Once you set it up, it's just like what we did earlier. You just have to be able to read the problem and set the thing up. Let's do the same thing with 14. But now, it says a ship's sonar finds that the angle of depression to a wreck at the bottom of the ocean is 13.2 degrees. So pretend, watch, that's the ocean, all right? Pretend it hits. We'll actually move it up just a little bit. So, okay. I'm not going to try to draw a boat or anything. All right, so that's where the sonar is at the top at the ocean, right? It's just at the surface of the water. And it says the angle of depression to the bottom of the ocean. This right here represents the bottom of the ocean. Is 13.2 degrees. That means this angle right here is 13.2 degrees. A big mistake people make is to put this big angle right here, 13.2. It's not. It's from the horizontal. We're assuming that the surface of the water is the horizontal. Down, that's the angle of depression. You with me? If this is 13.2, tell me something about the triangle, inside the triangle. That one, right, this one down here at the bottom is going to be 13.2. Give me a reason real quick. Why? Very good. Alternate interior angles, that's why that's 13.2 degrees. So we know this angle right here. It says, now sonar, what's happening? You know what a sonar is? It sends out a pulse, a sound, and then it kind of times how long for it to hit a surface and bounce back, and that determines how close you are to whatever the object is. It says if a point on the ocean floor is 75 meters directly below the ship, here's the ship right here, 75 meters directly below the ship, where would that be? It'd be right here. That's directly below the ship, isn't it? That's 75 meters, so that distance is 75. It says how many meters is it from that point on the ocean floor? From this point, how far is it from this point to what? To the wreck. Where's the wreck? The wreck is right there. So what are we doing? We're finding that distance. Thank you. Let me go on to the next video.